All right, this is it, the home stretch for your video key for the exam review, numbers 54 to 61. Let's do this. All right, so we're graphing a linear system and stating the solution. So this is where we graph both of these equations. So I'll graph that one in blue, and then I'll graph the other one in a different color, and we got to find the intersection points. So let's graph this line. Remember, this is our slope, 3/2. This is our y-intercept. The point is 0, 3, so we're going to start at 0, 3. And then from there, we can go up 3, right 2, up 3, right 2, or you can go down 3, left 2. And I might make more points later, depending on where the other graph is. Okay, so there's our first line. Our second line is x equals -2. So x equals -2, hopefully you know, is a vertical line at x equals -2. So that's going to go this way like this. And luckily for us, we already have our intersection point there, which is this point right here. So our solution is -2, 0. So that's the solution to the system. And then moving on to 55, same idea here. It'll be a little more complex because we have to graph two different lines now. So we'll do this one in orange. But same thing, you're going to start with the y-intercept of -1, which is right here. And then we have a slope of -2. So you go down to right 1 or up to left 1. And again, I'll draw more points on this line later if I don't find the intersection point based on the points that I draw to begin with. We'll just keep making points until the lines cross. Okay, so we have this line looks like this. This blue line over here technically should have arrows on it because it is going on forever. And then let's graph this line in purple. Okay, we have a y-intercept of 5, which is 1, 2, 3, 4, 5 right there, and a slope of -2. So down 2 over 1, down 2 over 1, making sure we have a negative sloping line. And so this line is going to look something like this. And so, well, that didn't come out very well. Guess I got to draw it all at once. All right, but maybe you can tell now that these lines are actually parallel. And because they have the same slope, if you look back here, that has a slope of -2, and so does that, which means they either always cross because they're the same line, or they'll never cross because they're not the same line, but they have the same slope. Here, they're not the same line because they have different y-intercepts. So here we have a no solution. All right, number 56, using substitution. So this is already set up nicely for us that x is equal to -2y plus 11. So we're going to plug that in for that x right there. So we have 3 times -2y plus 11 minus 7y equals -6. Distribute over here. So we're going to do 3 times both of these things and get -6y plus 33 minus 7y equals -6. Now we can combine like terms to get us -13y, and I'm going to subtract this 33 to the other side, which will give me -39. Divide by -13, you get y equals 3. Once you know what y equals, take that number, plug it back in to either equation, but this one's the easiest because it's already set equal to x. So now when we plug that 3 in, we get x equals -2 times 3 plus 11, and we get x equals 5. So 5, 3 is our solution to this system. And remember, you can always plug both these points back into both equations and see if they work. So I'm going to do that real quick in my head. Yes, that one's true. And yep, that one's true as well. So I know that that solution is right. Now we're going to do one using elimination, my personal favorite method. I notice here that I have a negative number and a positive number. So I want to try to make these numbers the same by multiplying the different equations by different numbers. So if I multiply this one by 3 and this one by 2, then for the red equation, I'm going to get 6x plus 10y equals negative 24. Make sure you multiply this number also. That's a common mistake. Students forget to do that. And then the top equation becomes negative 6x plus 9y equals 24. Now we can add these together to create a new equation. And you get 19y equals 0. These cancel out, which is what we wanted. And here we happen to get 0 too. So that actually works out nicely, because now you can divide both sides by 19 to get y equals 0. Once you know y equals 0, you can plug in 0 for y into either equation. I'm going to plug it into this one. And that will get me 3x plus 0 equals negative 12. So 3x equals negative 12. Divide by 3, and you get x equals negative 4. So our solution here is negative 4, 0 when written as an ordered pair. Again, I'm going to check that real quick in both equations, and it does work. I'm just plugging both numbers back in. All right, use the method of your choice. For this one, since this is already solved for x, I think it probably makes most sense to take 3y and just plug it in for x right there. And so you get 3 times, instead of x, 3y, plus 10y equals 38. This will get us 19y when we do 3 times 3, and then plus the 10y. So divide by 19, you get y equals 2. Once you know what y equals, plug it back in right there, and you'll find what x equals. So here we get x equals 3 times 2, which is 6. So we know we have 6, 2. Plugging that in real quick. Yep, that one works too. Excellent. This one, I think it's set up nicely for elimination because my x's are lined up, my y's are lined up, equals a number on the other side. And I notice right away I have a negative here and a positive here. So if I multiply this one by 4, I'll get 4 and negative 4 combined, which would be nice. So if I multiply by 4 here, I get 8x plus 4y equals 180. And the original equation for this other one is just 8x minus 4y equals 28. That's going to get me, when I combine these, 16x equals 208. And then divide both sides by 16 here. Divide by 16, divide by 16. And 208 divided by 16, of course you can use a calculator for that. And 208 divided by 16 is 13. So you get x equals 13. Once you know what x is, take x equals 13. Plug it into either equation. I'm going to plug it in for this x right here because there's no negatives, and this y is simpler than that y, I guess. But it doesn't matter. Whichever you choose is fine. So 2 times 13 plus y equals 45. So you get 26 plus y equals 45, which means y equals 19 after you subtract 26 from both sides. So our solution here as an ordered pair is 13, 19. I'm checking that real quick. It works in the first one. Second one, I'm going to use a calculator and check it. I'm going to do 8 times 13. And then minus 4 times 19. And I should get 28, and I do. So you guys can check that yourselves as well. All right, number 60, we're going to set up a system of equations representing this situation and then solve it using the method of our choice. 28 members of the ski club went on a trip. Members can rent skis for $16 per day and snowboards for $19 per day. The club paid a total of $478 for equipment rental. How many members rented skis and how many rented snowboards? So I'm going to use K is the number of ski rentals, number of people who rented skis, and snowboards, I'll use a B. B is equal to number of snowboard rentals. Okay, and we know total that 28 people went on this trip and rented stuff. So that means one of our equations is just K plus B equals 28. Then we know how much they paid total, and we know how much they paid for each thing. So it's $16 for skis. So we can say $16 times every ski that was rented, plus $19 times every snowboard that was rented is going to equal the total rent that was paid. And now here's a system of equations which you can solve any way you like. I'm going to take my top equation, the purple one, and multiply it by negative 16, because that will create a negative 16, whoops. That's going to create a negative 16k right here to go along with this 16k, which will be nice. So I get negative 16k minus 16b equals whatever 28 times 16 is. Negative 16 actually, which is negative 448. So now you can add these together, combine these, and you get 3b equals 30, so b equals 10. Once you know b equals 10, you can use the purple equation to find that k equals 18. And you get, this one you don't have to write as an ordered pair. If you did, you would usually write it in alphabetical order, but you don't have to. All right, final problem here. We're going to solve a system by graphing that's not just lines. So we have a line here and a quadratic here. Okay, so the line has a slope of 1 and a y-intercept of negative 3. So right here, and we have a slope of 1, so up 1 over 1, up 1 over 1, up 1 over 1, or you can go down 1, left 1, like in the other direction. And so that graph looks something like that. Now we got to graph this parabola and try to find where it crosses the line. So remember here, our vertex is going to be 3, 2. So 3, 2 is right here. Oh, sorry, 3, negative 2, because this is minus sign. So 3, negative 2, so let's move this down to where it's supposed to be. All right, and then what I like to do is I just make an XY table from here, and we're at 3, negative 2, so I'm going to plug in a number either one bigger or one smaller than the vertex, so I'm going to plug in 4 right here. 4 minus 3 is 1, squared is 1, minus 2 is negative 1. So you get 4, negative 1, which is right here, which means we automatically get a point here because of symmetry. And now we actually have found enough information to find that, but then we're going to have another one over here somewhere. So now I'm going to plug in another number because I know I can speculate that it's going to occur at 5, but I'm going to check and make sure. So I plug in 5 into here, and I get 5 minus 3 is 2, squared is 4, minus 2 is 2. So now I get 5, 2, which is right here. And so this parabola, so what I thought was going to happen is going to happen. And so my two solutions, you can either write just the x values, depending on how the problem is written. So x equals 2 and 5 were my solutions, right? Or you can say the intersection points 2, negative 1, and what was it, 5, 2. And there you go. That is it. Good luck on your exams, everybody. And hopefully you found these videos helpful.